Is there a certain way you recommend taking the exam because it's multiple choice? Like, should we start multiple choice, start short answer?
Well, so as one of my former colleagues would say, engineering students and engineers in general are really good at optimization. And I think that's the attitude you should have. I want to go in, I want to optimize my performance on the test. So I want to get the most points possible. So I like to start working problems, and if I see like, this is an easy problem, I just do it. And so should you start multiple choice first? Yeah, if you say, look, this is something easy, fun, let me get my 5 points for this problem. If you're like, this is going to take a while, come back to it. You have time. Now, remember that multiple choice problems, the way you solve multiple choice problems can be different than the way you solve long answer problems. Because it's not just about, I have to find the right answer. You can alternatively say, let me find the wrong answers and throw those out. And sometimes if you can find the wrong answers and throw them out, you can narrow it down to one. Or sometimes it's easier to say, okay, let me check which answers are consistent. Like if you were finding a plane, you're like, okay, I know the normal vector has to be perpendicular to these vectors, so instead of taking a cross product to find the normal vector, I can use a dot product to test if it's the right normal vector. So my advice is be efficient. Take the problems that are easiest for you. Don't miss out on low-hanging fruit. The problems at the start, the multiple choice, are not meant to involve many, many steps. They're meant to involve 2 or 3 steps. Now, unfortunately, because this is multivariable calculus, 2 or 3 steps could be like, well, a factor of 3 bigger than that, right? Because you have each slot you have to take care of. But the multiple choice should be pretty quick. So I don't have the best answer for like what's the absolute best way to do it. But I would say try to optimize, do what's best for you. The one thing you shouldn't do is get stuck on a problem. I don't know if it's ever happened to you where you just have a problem and you're like, I cannot leave this problem until I solve it, but I cannot make any progress because I don't know what to do. And so you just sit there. And time, unfortunately, doesn't sit. It keeps moving forward. So if you're stuck on a problem, what do? Move on. Do something else. And here's the crazy thing. When you get back to that problem, your mind has secretly been working on it, unbeknownst to you. It's very clever, your mind. And it says, you know what? Maybe you should try this. And the next time you come back to it, you're like, I have an idea. I forgot to try something. And oftentimes it works. Not 100%. But I think that there is definitely not a lot of usefulness for being stuck. So move around as needed. And there's not one right way to take a test. Find what works for you. I think the most important thing is to make sure you go in there. We mentioned this, it's not just this little corner of your mind that takes the test. Your whole self takes the test. So go in there as your best self, and make sure you've had, enough sleep the day before. Don't try to cram until 5 a.m. and then you have all your classes that you have on Thursday. Doesn't work out well. Eat some food, drink some liquid. Don't drink too much liquid. There's only a finite number of restrooms near the test, and it's very distracting to cross your legs for an hour. But take care of yourself. All right, sorry, I ramble a lot. As I like to tell people, I go off on tangents. It's why I'm a good calculus teacher. So, okay. All right. Anything else? All right. So the question that people wanted. Can we talk more about this finding a sub t and a sub n? And there's sort of a broad category that all fits together. So you have a list of things. And essentially, you have magnitude of r prime. You have magnitude of r double prime falls into this list. You have a sub t. You have a sub n. You have curvature kappa. You can even throw in some other things if you want, such as arc length. All these more or less relate back to the same set of tools. And these are carefully constructed problems. So these are ones where we rarely take suggestions from the audience. And these all hinge on that term, the magnitude of r prime. So somewhere on the exam, I would be very surprised if somewhere on the exam you didn't have to do this. So in other words, you should anticipate at some point somewhere there's a magnitude of r prime. Now, it could come in the form of a length problem. It could come in the form of finding a sub t or an a sub n problem. It's possible you might do both. So you want to make sure you know how to handle magnitude of r prime type problems. So let's work through this. Now, we're finding a sub t and a sub n. And so for this, you want to make sure you understand what things mean. So let's just remind ourselves, a sub t and a sub n, the a stands for what? Acceleration. So okay, so you know that this has something to do with acceleration. So that tells you, okay, I'm going to have to do something with derivatives of r. R prime and r double prime at some point have to come into play. What does the t stand for? Tangent. So tangent is saying with motion. So it's the tangent direction. What does the n stand for? Normal, which means perpendicular. So when we see normal, it's always coming up in the context of it's perpendicular. You know, when people say, it's another lovely normal day, and we say, yes, it is a very perpendicular day today. You know, that's our mindset now. That's our math mindset. Okay, so we know we're looking for decomposition of acceleration. So when we're finding that, step one for me is I want to find r prime, and I'll throw in r double prime. So I'll just take care of my derivatives right off the bat. All right, so let's start with r prime. What's the derivative of t minus 1/2 sine 2t? Okay, 1 minus cosine 2t. Great. How about the derivative of 2 sine t minus 2t cosine t? 2 cosine t. All right. Anything else? Minus 2 cosine t. Plus 2t sine t. All right. Derivative of 1/3 t cubed? T squared. Is there anything we should do before we take our next derivative? Yeah. Simplify. Before you take derivatives, and especially before you take integrals, you always say, boy, couldn't I make it simpler? And if the answer is yes, do it. All right. So let's do our r double prime. All right, r double prime. Derivative of the first term. 2 sine 2t. All right, because derivative of cosine is negative sine. So we're going to get rid of the negative. And we have the chain rule. The 1, derivative of 1 is 0. Okay, so these terms are gone. How about the derivative of 2t sine t? Okay, 2 sine t, product rule. So the derivative of the first is 1. That's why the t has gone away. And the derivative of sine is cosine. All right, and derivative of t squared? 2t. All right. So we found r prime and we found r double prime. Now, if we're doing a length problem, you don't need to find r double prime. Length problem only needs r prime. Okay, so now the most important step. Find the magnitude of r prime. Everything hinges on this step. So this is the one where your instructor spends the most time. We have to find something nice. And So look for nice algebra to happen is essentially what you should have in mind. Because we want things to turn out to be relatively easy to compute. So something nice has to happen. So why does there have to be something nice to happen? When we talk about magnitude of r prime, what's implicitly in that definition of the magnitude of r prime? Square root. And square root is, we do not like square roots. And so when we talk about look for something nice, an algebra nice thing to happen, it's we were looking for something where we can get rid of a square root. We are looking for the perfect square. Bum, bum, bum. All right. Good. Good. Okay, so. Magnitude of r prime of t is the square root of 1 minus cosine 2t squared plus 2t sine t squared plus t squared squared. All right. Well, not looking particularly promising right now. However, before we go too far, I will say this is a problem from an old exam, and there was a hint on the problem that I didn't write down on the screen. The hint said, hey, don't you know something about that? All right, so let's test your knowledge. 1 minus cosine 2t. What could that be? All right, I hear lots of sine squareds. That's good. Sorry, what?
2 sine of t squared.
Are you sure? Where's the 2 coming from? I'm writing it down.
The power reduction formula, sine squared of t is equal to 1 minus cosine of 2t over 2.
Yeah, it's like the power reduction formula, but in reverse. What? Reverse power reduction? That's crazy. But it just might work. All right. So this becomes the square root of, well, 4 sine to the 4th t plus 4t squared sine squared t plus t to the 4th. All right, that seems a little bit easier than if we tried to multiply out 1 minus cosine 2t quantity squared. And I'll point out that there's another reason why we should have that in our mind, in the back of our heads, which is we say, you know, this has a t on the inside for sine. This has a 2t. So this is like apples and different types of apples. So we don't want them to have a mismatch. And so there's sort of a motivation to say, okay, what can I do to get them to be more consistent? All right, now that we've written it in this way, does anything jump out and say like, ah? Anything?
Looks kind of like a polynomial.
It kind of looks like a square, right? It is a square. Oh, that's a bold statement. Well, it's true, because this problem was carefully handcrafted. If it is a square, what is it the square of? 2 sine squared of t plus t squared? All right. Should we check? If you square it, you take the first term squared. All right, that's good. The cross terms is like 2ab. 2 times sine squared times t squared. Oh yeah, that is 4t squared sine squared t. And then t squared squared is t to the 4th. Which means that the magnitude of r prime is 2 sine squared of t plus t squared. Now, you might be ever so slightly nervous when taking the magnitude of r prime. Do you need to worry about absolute value? And the answer is, yeah, maybe. Just check. Oftentimes you won't need to worry about it. Sometimes they'll say t is greater than or equal to 0, or they'll give you a range where absolute value doesn't matter. Okay, so we've done the hard part. Now the rest of it is fun. After you find r prime, the next step is a sub t. So, how do you find a sub t? Take the derivative of what you just found. So take the derivative of the magnitude of r prime. All right, so let's see, we can squeeze it up here. So a sub t is the derivative of 2 sine squared t plus t squared. What's the derivative of 2 sine squared t? 4 sine t cosine t. Derivative of t squared? 2t. And that's good enough for us. Now, if we wanted to, we could rewrite this. Is there a way to write sine t times cosine t in a nice, compact manner? Yeah, so this can be rewritten as 2 sine of 2t, double angle formula. So 2 sine 2t plus 2t. So here's our a sub t. All right, so a sub t, take a derivative. All right, now that takes us to our next step, 4. So suppose you want to find a sub n. What do you do? Well, it's the magnitude of r double prime squared. That's a sub t squared plus a sub n squared. And we have our pieces. So the nice thing is, because we're taking the magnitude of r double prime squared, then we don't have a square root involved. So we start taking our terms. So what's the square of 2 sine of 2t? 4 sine squared of 2t. And then plus 2 sine t plus 2t cosine t squared, whatever that turns out to be, plus 2t squared. That's the magnitude of r double prime squared. That has to be equal to 2 sine of 2t plus 2t squared plus a sub n squared. All right, and I'm running out of space, but that's okay. We have more paper. So, working on that left-hand side. 4 sine squared of 2t, and then we expand. So we'll have a squared, 4 sine squared t, 2ab, so that'll be plus 8t sine t cosine t, and then b squared is 4t squared cosine squared t, and then plus 4t squared. So I expanded out. That has to be equal to, well, we square stuff. So here we'd have 4 sine squared of 2t, then plus 8t sine t cosine t, that's this term multiplied out, plus 4t squared, plus an squared. All right. Now, on a side note, this problem, originally as written, you just had to find an arc length, so you just had to get down to that stage. But I thought, this is fun. Let's find a sub t and a sub n. All right. So, does anything happen? Four t squareds cancel, 4 sine squared t's cancel. 8t sine t cosine t cancels. Wait, what? Yes? No? Yeah? Okay. So what do we have? A sub n squared is 4 sine squared t plus 4t squared cosine squared t, which can be written as that. Yeah. It's not sine squared plus cosine squared equals 1. So how do you get a sub n now? Yeah, it's the square root of that. And There you go. Now you could do some various things if you wanted to, but I don't think it'll help us. So there's a sub n. Okay, so that's how you find a sub n. Now, suppose we wanted to go further. And he said, we don't want a sub n, we want kappa. What is kappa? Curvature. How do you find curvature? A sub n over magnitude of r prime squared. Now, if you're worried like, I'm going to have to memorize all this stuff, I will be honest and I'll say, if we ask you to find curvature, we'd at least give you this much information. So don't, if you're like, I need to like remove one fact, this could be the fact. But if you like to store stuff, okay, so can we write down our answer for curvature without doing any more work than what we've already done? Other than we have to write stuff. And the answer is yes, we can do it. Why? Do we know what a sub n is? Yeah, it's right there. It's the square root of 4 sine squared t plus 4t squared cosine squared t. Do we know what the magnitude of r prime is? Yeah, it's this part. You can't see it, but it does say magnitude of r prime. So this would be 2 sine squared t plus t squared squared. So yeah, we can find curvature. So essentially finding curvature is the same thing as finding a sub n. All right. Which is not actually, if you think about what curvature is, and I don't know how often you think about what curvature is, but it makes sense that there's a connection. Because what's happening? Curvature is trying to say how quickly are you turning. So high curvature, there's lots of turning going on. And low curvature says there's not much turning going on. So in terms of your intuition, what would we expect to be true? Well, if we have a lot of turning, let's start with where there's low turning. Here's my acceleration in the tangential component. What will my acceleration in the normal component be? Very small. So it's very small if there's a low turn, because there's not very much pulling me to the side. So the a sub n is what pulls you off to the side, whereas the a sub t is what pulls you forward or tries to pull you backward. On the other hand, if there's a lot of turning, what do we expect to be true? Well, a sub t will be relatively small, whereas a sub n will be relatively large, because there's a lot of effort to pull you off to the side. So it makes sense that it says, okay, a large a sub n should correspond to a high curvature. Now that's intuition. That's cool, but outside of what we need. Now other things you might want to know. What if we ask you to find t? So we found a sub t. How do you find t? And what is t? Okay, so you told us what it is, the formula, but what's the t representing? Yeah, it's the unit tangent vector. The fact that it says unit says you have to make something a unit vector. To make something a unit vector, divide by the magnitude. You say, okay, it has to be in the direction of motion. Hey, the derivative is the direction of motion. So take r prime, divide by magnitude of r prime, and you have t. How do you find n? Good luck. No, that's not how you find n. The way you find n is you have a sub n times n plus a sub t times t is r double prime. And then you say, well, I know how to find r double prime. I know how to find t. So I know how to find a sub n times n. It's r double prime minus a sub t times t. And that gives me the right vector, but the wrong length. So you just normalize that. In practice, don't worry about finding n. So just a side note. All right, so that was what somebody asked me to talk about. So that's why we spent half a class talking about it. That's it for the prepared stuff. Do you have any other questions?
Can we go over like the shapes?
Surfaces? Quadric surfaces. Okay, so quadric surfaces. Well, you have the cone. I'll start with that one. And you might say, how do you recognize if something is a cone? And here's the thing. I'm just going to tell you, we're going to put everything centered at the origin. So we're not going to have anything like, oh, x minus this, y minus that. No, everything's centered at the origin. So what you're looking for with the cone is you're going to have something x squared, something y squared equals something z squared. Something that will have this type of shape. Now, these are not zeros. They're just numbers. Now, I'm going to point out to you sort of what's going on here. When the reason I'm pointing this out. Okay, so cone has this type of shape. Now, we can, of course, turn it sideways if we just permute the variables. And I'm assuming you want me to say, how do you find it in terms of looking at the formula? Or do you just want to know what it looks like? Okay. Cross sections? Oh, okay. What do cross sections look like? Yeah, they'll look like circles. Or, what else could they look like? You're probably thinking other circles. If you do this cross section, what will you see? Not a parabola. Hyperbola. It's a hyperbola. Now, there's a reason that they call things conic sections. You can get parabolas if you take a weird cross section. Do you know the weird cross section to take to get a parabola? Yeah, you do it at an angle. So if you do that kind of a cross section, you do get a parabola. So, all right, so there's the cone. Let's see. We have the ellipsoid. Just think of it as the 3D version of an ellipse. And this can always be written as x squared plus y squared plus z squared. You could throw in positive numbers in front equals 1. And essentially it looks like a sphere that's been stretched and pulled. So what do your cross sections look like? Ellipses.
So if you have like an equation like that, but then you have like x squared plus x plus y squared plus z squared equals 1. Is that still
We're not going to ask you that.
Not?
Yeah.
It was one of the past exams I did.
Well, those punks. How dare they? So what it is, if you have like an x squared plus x, you do completing the square. And then it's like x minus a half, or sorry, x plus a half squared, so it's just a shift.
Okay.
So if you see it like x squareds and x's, it's just a shift in the x direction, is what it translates to.
This most likely be like one of our multiple choice questions.
Sorry, what?
So this most likely like the shape part of the surface would be a multiple choice question.
I would bet on it. I can't say yes, but I just would bet on it. And by the way, when it comes to multiple choice questions, each multiple choice has exactly 5 responses. No more, no less. So each one, if you guess randomly, you got a 1 in 5 chance. That's a bold strategy. We don't recommend it. There was once, years ago, when we had a kind of a similar flavor on a Calc 2 exam where you had to like circle. You know, there's 1 of 3 possibilities, and we gave you 5 things, and for each one you had to list absolutely convergent, conditionally convergent, divergent. And someone said, you know what, I'm just not even going to bother. I'm just going to pick a column, And I'm going to circle that column all the way down because surely, at least one of them must be right. No. Because the person who wrote that test said, I want to write this problem, but I don't want to have anything in that column. And we're like, yeah, go ahead. So don't try to second guess us. It's just like, oh, they haven't used the letter B yet, and I'm already to my 6th problem. I guess I got to have a B. No. We are not that creative. We are not keeping track of that. I once worked with a colleague back at UC San Diego, and they wrote a test, and it was kind of like multiple choice, but they gave partial credit for showing the work. And so they had like 4 options, and then they always include like none of the above. They didn't proofread the test very well, and so it ended up being like 9 out of the 10 problems it was none of the above. So, but you had to be really confident when you started heading towards your 5th or 6th none of the above. And so that's not this test. None of the options include none of the above. So, all right. So let me finish my rogues gallery here of shapes. So you have the cone. You'll notice something here. I'm going to do the hyperboloid of 1 sheet. And that looks like the hourglass. All right. And in terms of the formula, it looks like the following. It's x squared y squared minus z squared equals 1. So, in particular, again, arbitrary constants. So I'm not worried about the constants. But notice the ellipsoid plus, plus, plus. Hyperboloid of 1 sheet plus, plus, minus. What about the hyperboloid of 2 sheets? So the hyperboloid of 2 sheets sorry, it's so slow for me to write. It'll look like minus x squared minus y squared plus z squared equals 1. And so that's your 2 pieces. And you already saw it, minus, minus, plus. Okay, so you can, by sort of just looking at it and say, all right, if I see a number, and everything else is squared, I'm one of these 3. If everything's squared but I don't see a number, it's a cone. If everything is squared and I see a number, then I say, okay, let me rearrange it. Do I have plus, plus, plus? Ellipsoid. Plus, plus, minus? Hyperboloid. Minus, minus, plus? Hyperboloid. But 1 versus 2. Now what you might be saying, what does it look like if you have minus x squared minus y squared minus z squared equals 1? What is that? Nothing! Because you can't take a bunch of negative numbers, add them up, and get 1. Yes?
So does the hyperboloid of 2 sheets, does it still tail outwards as z gets bigger or smaller?
Yeah, it keeps going.
Like an inside out contact or something like that?
Maybe? I don't know. It looks suspiciously like a paraboloid, but we haven't talked about those yet.
Does it matter what variable has a negative? Like if the hyperboloid of 1 sheet
Right.
x and then plus y plus
Right. So using my advanced technology, I'm going to show you what happens. If I change it, they do something like this. So what will happen is, essentially, you see how this is the odd one out? That becomes the center. So 2 are plus, 1 is minus, the odd one out is the center. So if I switch the minus here and the plus here, then x becomes the center and it starts going sideways. Again, odd one out, it's the center. So if you switch which variable, it'll just turn it. So that's what's happening. All right. So we've done our hyperboloids, we've done our paraboloids, we've done our cone. What haven't we talked about? Paraboloids. Okay, so paraboloids, it kind of gives it away in the name. If I'm thinking paraboloid, what am I thinking? Parabolas. Okay, so there's two kinds. There's elliptic paraboloid. And you might call this a bowl. And so this looks like z equals something x squared plus something y squared. Now, the key here is the signs have to match. So it could be z equals minus something x squared minus something y squared. But the point is they have the same sign. They're both plus or they're both minus in the parts that are being squared. So two of the variables are being squared and one is not. If you see that, paraboloid. And then the question is, what are the signs for the parts that are being squared? If they agree in the signs, you've got your bowl. If they don't agree, then you've got what's called the hyperbolic paraboloid. But what's a better name for the hyperbolic paraboloid? Good. So z equals x squared minus y squared, or it could be y squared minus x squared, something like that. But the point is, one's positive, one's negative. You can have arbitrary coefficients, and then however you choose to draw a saddle. So I tend to draw my saddle something like this. All right, so I think those are your basic shapes we talked about. Have I missed any?
Is CC required to know about them?
No, because we can't. As a rule of thumb, we can't ask you to do something that we can't do. And so we never ask students to draw three-dimensional pictures beyond like really, really super crude drawings. Two-dimensional, we sometimes do. But even then, it's very limited. Okay, so those are your shapes. Other questions? Now that we've talked about quadric surfaces?
Can you go review stuff that's finding the volume, given inequalities, and it's an equation that will be inside of a spherical or
Well, so finding volume, the thing you have to look for when we talk about finding volume is there's only a couple of shapes we know the volumes for. So what are things we can find volumes for? Well, circles are two-dimensional, volumes are three-dimensional. Spheres. Okay, so what's the volume of a sphere? 4/3 pi r cubed. And you might be wondering, would we give you the volumes? I don't know. We have sometimes, we haven't other times. I don't know. What else can we find the volume of? Cone. What's the volume of a cone? 1/3 pi r squared h. Good. What else can you find the volume for? Cylinder. What's that? Pi r squared h. What else can you find the volume for? Cube. Cube. We'll say length times width times height. Ah, someone said parallelogram or parallelepiped. Parallelepiped. Oh, that's a fun one. Should we talk about that one? Yeah, parallel. That one's special. It gets its own color. Parallel, ... No, I can spell this. Come on. You spell parallel, and then you add a piped. Parallelepiped. Right? Easy. Everyone could spell that. Would this be a good word for the New York Times spelling bee? How many different letters does it have? 1, 2, 3, 4. I think this could work. We'll have to get in touch. So it turns out one of the editors for the New York Times crossword puzzles is married to a professor in the math department. And so we have an in. So if you've ever wondered, like, why does Ames show up so often as a clue in the crossword puzzle? We've got connections. So, all right. So, parallelepiped. What is a parallelepiped? It's like a parallelogram, but three-dimensional. Whoa! Okay, so it's a slanted box. All right. How do you find the volume of a parallelepiped? Whoa. People are doing it cross products and dot products. It's like, wow, that's so cool, and it takes a lot of work. Is there a faster way? Matrix. It turns out matrices are built for volumes of parallelepipeds. So, just for fun, since we brought up volumes, let's put some vectors here. What's the first vector?
1, 2, 3.
1, 2, 3. What's our second vector? 4, 5, 6. What's our third vector? 7, 8, 9. Ah, why was everybody afraid of 7? Yes, exactly. Good. And people say mathematicians don't have humor. All right. Now, if you have a volume of a parallelepiped, you could do the following. You could take the cross product of two of them. And then once you have the cross product of cross products of vectors gives you what? A vector, and the magnitude of that vector is an area. It's an area of a parallelogram. So if I took the cross product of these two vectors, it gives me the area of a parallelogram, and that's acting as a base. Then you have to find the height. And it turns out if you take the dot product with your cross product, so in other words, take the dot product with your cross product of the other two, that gives you your base times height, which is volume. Faster way. Take your first vector. Write it down. Take your second vector. Write it down. Take your third vector, and you write it down into a 3 by 3 matrix. You take the determinant of this 3 by 3 matrix, and now the fancy thing is you take the absolute value of that, and that's the volume. So if you have to find the volume of a parallelepiped, it's quick. Find your vectors, take the determinant. You didn't give me fun numbers to play with, but we can do it out. Should we do it? Okay. Do your diagonals. 1 times 5 times 9. 45. 2 times 6 times 7. 84. Good. 3 times 4 times 8. 96. Excellent. 7 times 5 times 3. 105, but you have to subtract. 6 times 8 times 1. Okay, someone's like, I've got to beat on this one. I know which one you're going to pick next, Steve. Okay, 9 times 4 times 2. Negative 72. All right. And now it's like, why is he going slow? Okay, all right. I'm not actually that fast. I just can multiply numbers. 45 minus 105, that's, if we put those two together, that's minus 60. Let's see, 96 subtract 72, that's plus 16. 84 subtract 48, that would be 36. 36 plus 16 is 52.
That's 14.
Wait, what's 14?
96 minus 72.
96 subtract 72?
Should be 24.
Okay, great. 36 plus 24. That makes 60. 60 subtract 60 makes 0. Now, is that a reasonable answer?
Absolutely.
Yes. What's an unreasonable answer? Negative. Now, you might say, wait, what happened here? So, what happened was your box collapsed. Because you gave me vectors such that it wasn't a really three-dimensional object. It collapsed down in a two-dimensional setting. All right, all that work. Okay, now this question, I will say when it comes to mathematicians, there's two numbers that they love a lot. 0 and 1. And so there's the old adage that if you're in a math class and the teacher asks a question and they say, okay, what's the answer? It's probably either 0, 1, or it's somewhere on the board. So that's what you're looking for. Now, in terms of finding volumes by inequalities, the key is think of the shapes. And since we only have a few minutes, but we have some time, I would say make sure you can nail your spheres, because we love asking about spheres. Now, when it comes to spheres, what tool do you need?
Complete the square?
Complete the square, right? You need to complete that square. So know how to complete the square. Why do you want to know how to complete the square? To find centers, and then also make sure you know how to find radiuses. So x minus h squared, y minus k squared, z minus l squared equals r squared. Center is HKL, radius is r. So make sure you know how to find your spheres and their centers. All right. Good luck. See you next week.